Thanks, Professor. My name is Tirth Vacheta, and my student ID is 101419772. My program is T177, and my course code is COMP3132. So I'm going to walk you through my assignment 1 submission. So the first cell, I'm going to be importing all the necessary libraries required, and then moving to question 1. What are the dimensions of train images, labels, test images, and test labels? Right here you can see the outputs. Going to question 2, the lengths of the train labels and the test labels, 6000 and 1000 respectively. Third question, showing the train and test labels right here. And question 4, I'm showing the digital content of the image index y in the training dataset. Running that, so you can see the output here. So question 5, plotting the image of the index phi in the training dataset right here. And moving to question 6, the label for the index 5 in train labels and what it means right here. Moving on to question 7, showing the digital content of image index 5000 in the testing datasets. You can see it right here. And moving to question 8, plotting the image of the index 500 in testing label dataset. Moving to question 9, the label for index 500 and what it means. The meaning is going to be like the label is going to be 2 and the meaning is dress. And for the question 10, I had already imported all the cells, like all the libraries in the very first cell. So it's just the same thing, but still I have mentioned the libraries I'm importing in messages, like as a comment. Answering question 11, 12, 14, 15, and 16 all together. Describing my network over here. Answering like the flattening the images, and then adding a hidden layer that has 512 neurons, adding one more hidden layer that has 128 neurons, and then adding a last 18 neuron dense layer that uses softmax. Perfect, that's the output. Moving to question 13, normalizing the image by dividing the image by 255. You can see the output for the function. Moving to question 17 and 18. That's gonna take some time. In the meanwhile, moving to question 17 and 18 as well. Again, within through a different approach. Trying to run both of them simultaneously. Perfect. So that's the option A done. Now moving on to the second. Till that time, I'll move on to question 19, which is like I would say theory based. How do you compare the fashion MNIST with what we have learned in the class using the same? The fashion MNIST dataset is an advanced alternative to the MNIST dataset, which consists of handwritten digits. While both datasets contain 60,000 training images and 10,000 test images, they differ significantly in complexity. The dataset comprises grayscale images of the digits 0 to 9, making it a relatively simple classification problem. In contrast, Fashion MNIST contains images of various clothing items such as t-shirts, trousers, dresses and shoes, which introduce more common complex textures, patterns and variations. That's question 20. What can we infer from the differences in the accuracy? What could be the reason for that? Explain in your video. The difference in accuracy between the Fashion MNIST dataset and the traditional dataset can be attributed to several factors related to the complexity of the dataset. MNIST achieves a higher accuracy compared to Fashion MNIST. This difference can be explained by the nature of the images in both datasets. MNIST consists of handwritten digits, which have simple, well-defined shapes with minimal variations. In contrast, Fashion MNIST includes clothing items like t-shirts, shoes, and coats, which introduce more intricate details, variation in textures, and overlapping features. One more key reason for this accuracy gap is the difficulty in distinguishing similar classes in the MNIST dataset. For example, a t-shirt and a shirt may have similar outlines, making it harder for the model to differentiate them. In contrast, the MNIST digits like 2 and 3 have distinct structural differences, making them easier to classify. So that's almost done. The option B. Perfect. And now we'll be calculating the loss and accuracy. So as you can see, the accuracy is 88.46 and the loss is 0.5520. 0.5220. Thank you.